Greetings guys and welcome to today's lesson. This is actually lesson 2 of our investment appraisal techniques. On the lesson 1 we were talking about the simple payback period, but on the today's lesson we are going to be answering the question 2 of our exercise. So today we are going to be calculating the discounted payback period. So without wasting much of your time, let's dive straight into the calculation. I'm going to show us the calculation again so we can recall what it was all about. So the question reads thus: a business is comparing two alternative investment projects. Project 1, an investment in a new machinery, cost 90,000 francs, or project 2, the purchase of a retail outlet at a cost of 90,000 francs with a discount rate of 10%. The expected net cash flow for each are: project 1 will have 20,000, 30,000, 40,000, 20,000 and 20,000 for the 5 years respectively. Then project 2 has 10,000, 20,000, 40,000, 60,000 and 50,000. So on today's lesson we are going to be focusing on the question 2 of this exercise, which demands us to calculate the discounted payback period and decide which project should be chosen. So let's go straight into the solution. So first we are going to be focusing on project 1. We are going to calculate project 1 first, then project 2 after, so we can compare both and see which one we are going to venture into. Remember, unlike the simple payback period, we are going to introduce the discount factor in order to determine the discounted payback period. So the discount factor here is helping us to include the time value of money. Remember, we said investment appraisal methods were divided into two: the ones which do not take into account the time value of money, for example the payback period, simple payback period, which we did in the previous lesson, and the ones who take into account the time value of money, like the discounted payback period. So we are going to be introducing the discount factor, which uses this formula: df, which is our discount factor, is equal to 1 plus r power negative n, where our r is the discount rate, n is the year. So moving ahead, we are going to be introducing a new column which we are going to be calculating our discount factor of 10%. So substituting the formula or the figures in the formula, we are going to have for year 1 0.901, which is calculated as 1 plus 0.1. 0.1 here is the discount rate of 10% as was given in the question, power negative 1. Negative 1 here is year 1. So we're going to do same for the following years. So year 2 is going to be 0.8264, which will use the same formula, but the difference now is we are going to use power negative 2 because it is year 2. So we are going to be doing same for year 3, year 4 and 5, which will give us these figures respectively. Alright, so we are going to be introducing another column, which will be our discounted cash flows. In order to calculate our discounted cash flows, we are going to take project 1's cash flows, multiply it by the discount factor to give us our discounted cash flow. So let's go ahead and add the new column. Okay, our new column for the discounted cash flow, remember we said we are going to be multiplying A, which is our discounted cash flow, and B, which is our discount factor. So multiplying it, year 1 will give us this figure, year 2 will give us this figure, year 3 will give us this, year 4 will give us this, and year 5 will give us this. So next we are going to go ahead and add another column for our cumulated discounted cash flow, same as we did in the previous lesson where we were calculating the simple payback period. We have to accumulate the we have to accumulate the cash flows. So we are going to follow the same procedure here. Let's go ahead and include the new column. Okay, our new column here for accumulated discounted cash flow. So year 1 is going to maintain as 18,182 because there is no previous year before year 1. So we're going to maintain the figure. So we're going to plus it. We are going to plus 18,182 to 24,792, which will give us 42,974 as cumulated discount cash flow for year 2. We are going to do same for year 3, 4 and 5. So if we plus this to year 3's discounted cash flow, we are going to get this. If we plus this to year 4 discounted cash flow, we are going to get this. And if we plus it to year 5 discounted cash flow, we are going to get this. So please, if you haven't watched our previous lesson which we solved the simple payback period, I think this is going to get a little confusing for you. So please, you can go back to our previous lesson and watch before you continue with us. Thank you. So as seen from here, we are going to be introducing our simple payback period formula, which we are going to use to determine our payback period. That is the time this investment took to recover its initial cost outlay of 90,000. So the formula goes thus: we have A plus B minus C divided by D, where A is year before full recovery, that is year 4. We have B, which is our initial capital of 90,000. We have C, which is our accumulated discounted cash flow of A. Remember we said A is year 4. And we have D, which is the discounted cash flow of year A. Remember we said A is 4. So the year after A should be 5. So we are going to consider the discount cash flow of year 5. So going ahead to substitute the formula, we have something like 4 plus 90,000 minus 86,686 divided by 12,418. Calculating this, we are going to get 0.27, which we are going to now convert to months. So in order to convert to months, we have to multiply 0.27 times 12, because 12 is the number of months we have in a year. So multiplying this, we get the answer 3.24 in months. Now we are going to convert the 24 that's behind the 3 into days in order to get our answer in the nearest days. So we are going to take 0.24 times 30, which 30 indicates that we have 30 days in a month. So multiplying this will give us 7 days. So this means that project 1 is 4 years, 3 months and 7 days, indicating that our discounted payback period for project 1 is 4 years, 3 months and 7 days. So I'm going to leave you guys with an assignment to do the calculations for project 2, so that we can use to evaluate this project to see the one which is worth taking. So assuming you have done for project 2, and I'm trusting the fact that you have something like this for your project 2. So if you have done your calculations, where you should get the discounted payback period for project 2 as 3 years, 10 months and 9 days. So that said, let's go ahead and compare both projects using our discounted payback period to see which project we are going to take as far as this technique is concerned. So as seen, project 1 takes 4 years, 3 months and 7 days, while project 2 takes 3 years, 10 months and 9 days, indicating that project 1 takes a longer time to recover its initial investment than project 2. So we choose project 2 because it has a shorter time frame of recovering its initial investment of 90,000, unlike project 1, which takes a longer time frame of 4 years, 3 months and 7 days. So note, overall, using the payback period technique, despite if it's the simple payback period or the discounted payback period, we choose project 2. This is because the discounted payback period takes into account the time value of money, unlike the simple payback period, which does not. So the discounted payback period is the most effective payback period technique to evaluate a project. Thank you guys for watching today's session. I'm going to be seeing you in the next lesson, where we are going to be continuing with our exercise. We are going to be answering question 2 of the exercise, which is net present value. That is another discounted appraisal technique for project evaluation. Thank you guys, and stay tuned for our next lesson.